wants to see the recording later. So what I want to do today is just a few things that I would like to mention. Probably some of you have heard from the past generation, like the class last year, last semester, last term. I did last term with the students of this subject, and I usually do it with my other classes of deep learning. I do this NVIDIA certification, like fundamentals of deep learning certification. So some of you might have heard of it. Some of you might not have heard of it. So my intention is also to do it. Last term, I did the certification with the students of this class, and my intention is to do it this term again. I am certified to teach a few courses by NVIDIA, a few NVIDIA courses, and I am in a program that is called University Ambassador. So by being an NVIDIA University Ambassador, basically what that means is like it has other subtleties, but one of the main points is like an offer NVIDIA courses. Well, those NVIDIA courses that I'm certified to teach for free to my students or to other students, as long as it is students. So what I want to do is to do two courses. The first one would be the fundamentals of deep learning, which is a very basic course, which is basically everything we have seen up to week 5, probably 4 or 5, with a lot less detail than we have seen it. It covers until convolutional neural networks, but I think it's a very nice way to wrap up what we have seen so far. So that's the first thing I wanted to talk about. So I would like to agree on a date to have the course. I know not everyone is going to be here, but at least the recording is going to be here so that everyone can see this conversation I'm telling you. And I think the date is going to be, I would like to do it on week 7, but maybe it will have to be on week 8, week 7 or 8. That would be the fundamentals of deep learning. It covers everything until convolutional neural networks. So it's going to be a nice way to wrap up everything we have seen so far. And actually, it's a nice way also to validate that what you have seen and studied so far is actually valuable, right? So I think that is kind of nice. I don't know if any one of you or from the class has already taken the certification. If you have, then well, you don't have to take it again. You can enter if you want to, but you don't have to. So, but what I would like to do, sorry, was there a question?
Yeah, no, well, I was going to say that I enrolled for the certification that we are taking this Sunday.
Okay.
And it's the fundamentals of deep learning.
Yeah, this one was one that I opened, like, it's just an experiment I was doing. I thought, like, it was 2 years ago, I thought that NVIDIA organized this certification for Latin American students. And I was invited to teach the course, and I taught it, and it was kind of nice. I mean, like, because we had people from everywhere in Latin America. So since this, I think this year they didn't do it because it was in February, and I haven't had any notification. I mean, not that I was invited, but I mean, like I usually get the email saying that there is this help us distribute with your students, and I haven't gotten anything. So I'm assuming that they are not doing it this year. They did it last year because last year I also was participating in that certification, but still. So if you have already enrolled, that's all right. I mean, you can enter again. You may not. Doesn't matter. There was another. Yeah, the one of diffusion models. My intention would be to do it in week 10 or week 11. Yeah, that's something that I couldn't do last time with the previous generation because it was in December, and I had to travel in December, by the beginning of December, so I couldn't arrange it. And then by the time I came back was already like the late second week of December. So it was like, okay, holidays coming, and it was kind of tricky. So that's why I'm doing that one until the 15th of February. And I asked the people, well, by the end of the term, I sent an email, an announcement in Canvas to the previous group. Whoever is still interested in taking this, let me know, and I will organize it next year. And this is the one I'm doing mainly for the people from the previous class, but I intend to do it for this class in particular. So, because I also got an email from someone, asking about that. So if you want to take that certification of diffusion models, I mean, I'm intending to do it for this group particularly. So that would be like week 10 or week 11 of this class. Was anyone going to ask something?
Yes, I have a question. Well, I also saw that there is another certification about generative AI. I
Well,
don't know if.
well, it depends on what you're referring to, because the diffusion models is Gen AI. I mean, that's
Okay.
that's the model behind like Stable Diffusion and DALL-E and this kind of draw the picture of a dog. I mean, that's
That's the course.
Gen AI. Yeah, that's one of them. I mean, there are other Gen AI models like and courses that I can also teach, but that one I don't know. Maybe I'll do one later on, but not I don't think I will have time to do that many, which has to do with LLMs. That you could also consider Gen AI, but diffusion models definitely is generative AI, and that's going to be. I'm planning to do that on the last week, 10th or 11th week of the. I mean, is the 10th is the last week, but 11th is like the week for the review period. So one of those 2 weeks, my intention is to do it for this class in particular. I mean, like especially for this class. So yeah, I'm going to do the diffusion model in case you heard of it and you wanted to join and couldn't, or if you have already joined for the one on the 15th of February, that's fine. I mean, you don't have to take it again, or you could take it again if you wanted to. That is totally fine. All right. So just wanted to say that because I had forgotten to tell you before. So I reckon that the first one will be like week 7 or week 8. I mean, this is week 5, 6, 7. Yeah. I'm trying to look at it. It might be 14th. I may try to do it for the fundamentals of deep learning. I think we can do it fairly quickly. It was like that last semester because everything covered in the course we have seen with a lot of detail. So really is more a way to wrap up everything and get the certificate, because that's nice also. So you get the NVIDIA certificate with a link that you can actually validate that is legit. So that's probably one of the main reasons. But we have seen everything with a lot more detail than it is covered in the certification. Because in the end of the day, the certification is intended to be taught in, I think, 8 hours, 7 hours, because it's 8 hours plus 1 for lunch. So no, that of no space is available. I mean, what I'm saying is that the no space is available for. Okay, you guys are VIP, so I'm doing especially for you. So don't worry about that. I mean, the ones that I announced in the YouTube video and the one that I'm doing for the previous generation of this class is to do with. I mean, that's why they are full. I mean, I'm saying that I'm doing the deep fundamentals of deep learning, especially for this class. So it's going to be the 105, 6 places. In case someone has already taken it, there's no issue. I mean, there's no issue. So
Professor,
yes, please.
How about doing it after the midterm exam?
Yeah, it's going to be after the midterm.
Okay.
Yeah, the midterm is going to. That's the point I want to talk. But let me just let me finish this, and I'll talk about the midterm.
Sure.
Okay, so week 7 or 8, week 6 is next week, if I'm not wrong. Week 7 would be in the 21st of December. So it will be either, because I know that most of the people here work, probably a Saturday is a better day. Doing it in Saturday morning. Last time I did it in a Friday, like 3 p.m. So also it worked. I mean, it was like, but so let me just check it. It's usually, I should need to ask because the way they work is that I have to fill in a form with NVIDIA form, and ask for a number of virtual machines, and then they allocate the number of. Sorry, pardon.
You say frog, we jump.
We say what? Pardon, I think.
You say frog and we jump.
Yeah. Okay. Okay. Thank you. Yeah, I just want to make I understand that many of you have to work, right? Or have jobs that don't allow you to join like at 3 p.m. on a Friday. So that's why I'm thinking on a Saturday, but particularly for the first one.
Maybe if you let us know with enough time, I mean, most of us will be able to save that time for that class, you know?
Yeah, if that's the case,
Even if it's
last
Friday.
time I think I did it Friday, 4 p.m. And we finished like at 11 p.m. on the Friday. It was a little bit tiring, but it was all right. I mean, most people were capable of joining. Also, because it's the first certification, and as I said, you have seen everything. We can go really fast on that one, and we can finish it in less than 6 hours usually. So that's why I'm not like so concerned about that one. The second one, the one on diffusion models, that has to be on a Saturday, because that will take exactly or probably more than 8 hours. I mean, we will take 8 hours, but the diffusion models one is a really nice one, but it's not an easy one. I mean, so that in that one we will have to cover I mean, to follow the script that I have to follow as an instructor. In the one for fundamentals of deep learning, I think I have a little bit more freedom because you have seen everything. So I don't have to cover all the basics. I mean, like we start from what's supervised learning and what's like cats versus dogs and things like that. So I don't have to cover that with you. So that's why I'm thinking that the first one we can do quickly, mainly focus on you doing the exercises, the notebooks. So the first one I don't think is much of an issue. So I will try to do it for the week of the because for the week on the 21st, my intention would be to do it the 21st or 22nd of February. Okay. So I will put an announcement in Canvas, and I think the 21st of Friday 21st would be all right, I guess, or Saturday 22nd. Is anyone here? Well, it's just that this is a small sample of all the classmates. Yeah, but I will probably it's going to be I don't know. What do you think here? Knowing your classmates, do you think Friday afternoon is all right, or would you think it's better to do it on a Saturday morning?
I actually think that for this topic, Friday or Saturday is gonna be okay because we like it. So I think most of the people is gonna be in.
Okay.
That's my feeling.
I agree.
What do you think?
Okay.
Yes, I agree.
Sorry, Jorge, were you saying something?
No, I was telling that I think the same. I mean, I agree with you that Friday, Saturday will be.
Either Saturday or Friday. Okay. Okay.
I think that for what I have seen is that most of us we have Saturday free because it's where the time that we use to do the assignments and pending topics from the master. So I think that Saturday could work for most of us. But if there is no option, Friday. I mean,
No,
if
I
we
mean it could be a Saturday. I mean that's why. Yeah, I mean, and we can do it like Saturday 9 a.m. and I think by I don't know, probably 2-3 p.m. will be done for the first workshop. Yeah, so I think that would be all right. Probably I can do it Saturday the 22nd. I can ask for that one. So that would be that would be it then, I guess. So Saturday. And then the last one that is going to be, I just need to check the dates because I was thinking to do it in the, like right now, I just checked the dates and I know that the 28th of February, I'm going to be in Monterrey actually. So it would be difficult for me to do it that weekend. So it definitely has to be on the 22nd. So week 7 is going to be week 7. I think I'll program it. I'll just check that there is nothing on Saturday, but it will be either the 22nd Saturday in the morning, 10 a.m. Also Sunday works, but Sunday sometimes is tricky for some people. And then, or Friday 21st. I will let you know. I think I'll put an announcement tomorrow morning. I'll just check the dates and let you know. And so the second one is going to be on the week 10th. That would be 7, 8, 9. I think that's going to be like the second week of March. Maybe the 14th or the 20th, no, 15th or 22nd of March, something like that. that will be the second workshop, which is going to be about diffusion models. And for that one, that's a longer workshop because we have to take everything. And then that is a very nice workshop, the diffusion model. And it goes well because it's the last week of the course, and the last week of the course is intended for diffusion. So that's cool. So yeah, so that was the first thing I wanted to talk about. So yeah, I don't know if there's any other question about this. Okay, yeah, it's going to be on Saturday then, I think. Yeah, someone said.
Well,
So
I do have a question, but it's
Yes.
not related to the certifications.
I think, yeah, we can go on with that. The other thing I wanted to mention is the quiz. So the quiz is going to be next week. Quiz is going to be opened from usually it's Thursday. So there will be no session next week. So next week we are not going to meet. And the idea for next week is when I was studying like the masters in the UK, they have this thing they call the reading week, which is kind of nice. It's a free week in the middle of the term so that you can do catching up mainly. In this case, the idea is that you can have a chance to review whatever material you're for any reason you didn't have time to review, or you want to double check, triple check, whatever. So that's the idea of that week. And then from Thursday, the quiz is gonna be open. So you will have Thursday till I think Monday or Tuesday to whenever you want to do it, you can access the quiz. The only thing you have to be aware is that once you access the quiz, you have 2 hours to complete the quiz. Everything is multiple choice. Well, there might be a few questions in the end that are not multiple choice. There is a unique answer though, because they are numeric calculations. So, but yeah, it's going to be. Usually you can answer the quiz in less than 1 hour. I mean, taking your time, less than 1 hour will be enough. Still, you will have 2 hours to complete it. Yeah, and it's going to be covering everything until week 5. Okay, so everything till week 5. Yeah, and of course, I mean, the fact that you are taking it on your own time, you are welcome to. My advice would be, at least, you are welcome to check any of the materials. Like you can check books, you can check whatever. I don't know. I haven't tried asking ChatGPT if ChatGPT can get the exact answers. My advice would be maybe not do that, but still I cannot control if you do it or not. Right. So my advice would be try to do it. It's not complicated. I mean, is to do exactly with what we have seen so far. Some of the tricky questions, they are not tricky, but be familiar with how to calculate the number of parameters of a neural network. So that might come in the quiz. Everything else is like very basic, fundamental understanding of neural networks, and everything is covered until week 5. Okay. So just to summarize, quiz next week. Next week we are not meeting, and the quiz is going to be open from Thursday. You will have 2 hours to complete the quiz. Thursday till, I would say Tuesday. Yeah, I can leave it all the way till Tuesday. And then you will have, once you started, you have 2 hours to complete it. And you will have 2 tries per question. I don't remember if it's 2 tries. No, I think you can answer the quiz. Like if you get an 80 the first attempt, you can do it again and to try to improve your score. You can do the quiz again. Yeah, that's what I'm trying to say. You have 2 attempts for the quiz. Like you can.
Can we do the quiz with my teammate?
The idea is to do it individually, but I cannot control if you do it with your teammates. My advice would be like for everything that you are doing, for every homework, I mean, try to do it individually. Be sure that you can do it individually. And if you want to work in teammates, I think there's no problem with that. I really don't see an issue. But my advice is understand the questions and try to get to the answers on your own. And not just because, I don't know, any of your teammates came to the answer and just, right? That would be my advice. But yeah, you could, of course you can, yeah. When I do normal classes, like not remote, like I usually give the students, like in the quizzes, I like 10 minutes when I go out, and I told them you can talk to anyone you want to. So it's interesting, that part of the exam. So yeah, why not? Yeah. Questions are about what we have seen is like theory, formulas, and math stuff. Like formulas, I wouldn't say many formulas. What I just said is that be familiar and be confident to understand how many parameters there are in a neural network. That's relevant, and those kind of questions make for nice quiz questions. So yeah, yeah. And the other thing of the quiz that I said is that you have 2 shots for the quiz. Question. Yeah, you're welcome. Question from the homework professor: in the pre-trained models like BGG610 or DenseNet, the architecture after the convolutional layers include a block of fully connected layers and dropout. Yeah. Okay, I probably would need to see the question with more detail, because regarding the activity, the question here regarding the transfer learning activity, there are a few ways to do this. And probably the tutorial that I provide is like the hard way to do it, where you actually enumerate and loop through all the layers, and then you remove the number of layers almost one by one. So you can actually say, okay, I'm going to keep all the layers up to the layer -2 in that loop that you have, when you're running all the layers that you're keeping. I can't remember now the command, and I don't know if that question relates to this, because there is an easier way to do that in PyTorch, where you can actually remove, like, I can't remember if it's like include head or something like that. I can't remember the command right now. So I don't tend to do it. I tend to do it like I learned to do it in the for loop, and that's how I keep doing it. But there are better ways, like more efficient ways in terms of, I mean, in the end of the day, the effect is the same, but you can actually have like, I can't remember the instruction. Actually, in the workshop, in the NVIDIA workshop, you will see that option, right? Of just having a parameter, that hyperparameter that would be like include head, not include head, and it removes everything. So if you're doing something like that, I guess that is going to remove all the linear layers in the end. If you want to be more specific about how many layers to remove, you can do the for loop, and that will allow you exactly more granular control. Right?
Okay. Thank you, Professor.
No, good question. Thanks for asking.
Yes, because in a sequential layer, we have several operations like ReLU, linear, and the question is if we delete all the sequential layers, we can put all the layers?
You can put whatever you want to. Whatever you want to. Like what we were, for instance, just to mention an example. If you remember from last week, I was talking about a paper that was from a project from a previous master student. And within all the configuration that he was trying, that I was showing you, the one that had the best results was using a pre-trained ResNet 18. That was like the backbone of the network. And then on top of that, it was a 3-layer convolutional neural network. And that 3-layer convolutional neural network was pre-trained also with the single 3-layer convolutional neural network that he made as an initial experiment. I don't know if you recall, but the initial experiments were like, okay, 1-layer convolutional neural network with the data, all the spectrograms, and you get some result, bad result, really poor results. 2 and also 3 layers. But then combining the ResNet, pre-trained ResNet, with the 3-layer convolutional neural network, also pre-trained, and then fine-tuning on the convolutional neural network led to the best results. So you can keep whatever you could also like we have the backbone of convolutional neural networks from ResNet or BGG or Inception or whatever model you're using. You could also go, if you go with a for loop, you could remove like, okay, I want to keep only 15 layers from the ResNet 18. And for whatever reason, I mean, if you want to keep like only half of the convolutional layers in the pre-trained model, you can do so. Yeah, you have that granular control of removing whatever you want to and keep whatever you want to and putting on top of that whatever you want to. You just have to be aware that sometimes you might need to do some matching in the dimensions that you might have to allocate for that. And as long as you are very aware of what's the dimension from the point that you are cutting the network, like depending on the model, it might be that the last activation volume that you have is, I'm going to say an example, is 64 times 64 times 512. Just be certain that whatever you put on top of that matches those dimensions, right? And apart from that, it's perfectly fine to do whatever you want to do. Also, you might have noticed, you might have not, this is not obvious, but when you're using pre-trained models, like say you're using ResNet, I like a lot of ResNet because ResNet 18 is kind of efficient to train in most hardware. Like it's not that complicated. If it's pre-trained, you can usually run it and load it. But all these models were pre-trained using ImageNet. So ImageNet images are 224 times 224. And so in the end, you pass it through all the layers. And by the end, I'm going to say, I think it's like 7 times 7 times 512. Say that's the output volume in the last layer, the output of the last convolutional neural network. It might be different, but let's just assume that you have 7 times 7 times 512. So depending on how you do it, the best way to do it is that when you are starting your images, if your process, sorry, if your images are, say, I don't know, I'm going to say 128 times 128, you usually rescale them to be 224 times 224. Or if they are higher resolution, say that they are 512 times 512, then you rescale them to 224 times 224. That's usually the initial transformations that you make. You try to match the input data to the characteristics of the images that the model was trained with. Okay, so ImageNet 224 times 224. So you try to rescale the images, or you rescale the images to that dimension. And that's the best thing you can do. I mean, you should do that. Having said that, if for some reason you don't do it, and you pass your images that are 128 times 128, you will see that your output volume is different. I mean, it has different dimensions, but you will see that it works. I mean, that even because the expectation might be that if you don't resize the images to the size of the original ImageNet sizes, you might think that there would be an error in the process, right? Because you have to match in the end of the model, ideally you should be matching the dimensions of the output volume when you're doing the flattening and all this to the output layers. But you could see that even if they are another dimension, say 512 times 512, and you run your images like that without resizing, you will see that they run. Depending on the model, but most of those pre-trained models run. And just to mention this, maybe some of you have noticed, maybe not, but in case you have noticed or you have seen it and you were wondering why this is the case, if you see, and this is very important, well, it's important, you will see that the last layer prior the linear layers in the pre-trained models, like ResNet, for instance, instead of doing a flatten of the output volume, say the output volume is 7 times 7 times 512, instead of flattening this volume into a single vector whose dimensions are 7 times 7 times 512, whatever that product is, what you're doing, you will see that there is a layer that says like average pooling. I think the name is a little bit longer, but it's an average pooling in the end of the day. And what this layer does is that instead, and this is commonly done in practice, is that instead of, and probably I can write this Android, I think it's going to be make more explicit. Let me open the, I managed to find the whiteboard. No, sure. Where's the whiteboard? There we go. Right. Let me just share the whiteboard and new whiteboard and put it here. So hopefully you can see the whiteboard now. And let me see. Oh, this is not my pencil.
Yes.
Okay, so second draw. So say that you have the convolutional neural network, and by the end you have this kind of volume. That is 7 times 7 times 512. So if 512. So if you just flatten this one, you will have a vector whose dimensions are the result of 7 times 7 times 512. Whatever this result is, whatever this number is. And you will have these dimensions. But more commonly in these models, in these larger models, what you do is something that is called, it's a type of pooling. It's average pooling. It has another word in the name, but you will see that there is that the layer in between the last activation volume from the convolutional neural networks and the linear layers will have this kind of average pooling layer. And what it does is that instead of just flattening all the dimensions here and converting them into a vector, what they do is that, okay, they take this activation map and take the average of these 7 times 7, 49 values, take the average of that and compute only one value. And then for the second channel here, they do the same. And so in the end of the day, they will end up with a vector, with a volume, say, let's call it a volume, that is 1 times 1 times 512. Because every channel, every little channel here, is the average of these 49 values, 7 times 7. Also for this, 7 times 7, and so on and so forth. So instead of just flattening, as we would normally do, you take the average of these, of all the values in every channel. So instead of having this product, you only have 512 values. That's the reason why, if you start with the images that are 512, oops, I don't like this, it doesn't write. 512 times 512 instead of 224 times 224, in the end, you will have something here different. It might not be 7 times 7, but it might be that the dimensions are 14 times 14, whatever the dimension is in height and width in the final activation volume. So it doesn't matter, because in the end of the day, since the average pooling layer will take the average per channel, in the end of the day, instead of taking the average of only 49 elements, you will take the average of, say, 14 times 14 elements. And so, but in the end, you will end up with 512 values. So there wouldn't be a mismatch in the dimensions. And so you don't change anything, and it seems like it shouldn't work, and it works, but the reason is that. Because in the end, you are not just flattening, but you have like this layer that will take the average per channel in the final activation volume. Okay? Does this make sense? No. Cool. Cool, thank you. Let me see if there's any other question. I think there's something preserving the model. I add the layer, including the trained classifier. At the end, I add the layers to adapt it to the Cypher-10. Yeah, absolutely. I mean, whatever you do in the end of the day is to keep the pre-trained part, and you can do whatever you want in the end. I mean, you can add more convolutional neural networks if you wanted. Layers, sorry. More convolutional neural layers if you wanted to, and it works. So yeah, absolutely. The most common way to do pre-training, like if you were to have a cookbook kind of recipe, it would be, okay, get the model, get the pre-trained model, pre-trained usually on ImageNet. Remove all the linear layers. Replace them with 3 or 4 layers, linear layers. Do the freeze the body of this pre-trained model, the convolutional neural net layers. Freeze them, 15, 18, whatever the number of layers that is, just freeze them. And then run the images with your data. Your data usually is going to be like quite limited because that's the reason you're doing, well, one of the reasons you are doing transfer learning, because you don't have enough data, you don't have enough compute. So freeze the model, freeze the big part of the model, but you don't train that. Run your data, limited data in the entire model, but you only adjust the final layers, the ones that you have replaced. Adjust them, you adjust those layers. And then you have a better model now that is kind of aligned with your data, and it works better. Now, having said that, that's kind of, okay, the first step. Now, you want to increase performance, and this is like the final step. Okay, you did this kind of training, right? Now, say that you updated your final layers, your 3 or 4 linear layers that you place in the end of the model. Say that you trained them now, you have trained them with, say, a learning rate that was, I don't know, 1 × 10⁻², just to say a number, for 100 epochs. And it works. And now you see you have a model that is fine-tuned, kind of fine-tuned to your data. It is working well with your data. Now, and you are getting like 95% accuracy. Now, something that may improve a little bit your model, your performance, is, okay, all this body, all these convolutional layers that I have frozen, I kind of defrost them. What that means is that instead of having the use gradient equals false, I will say use gradient equals true. And so what I do is, okay, I will defrost them, like unfreeze them, allow to train them, but now I will use my learning rate is going to be smaller, say 1 × 10⁻⁴, 1 or 2 magnitude orders smaller than the original learning rate, and then train again. And instead of doing 100 epochs, I will do probably 5 epochs, very, very few epochs. So very small learning rate, very few epochs, and I train for those few epochs. And that usually increase performance like 1%, 2%. So that might not be that significant, but might be relevant for certain applications. And that process is called fine-tuning. So that would be like the whole transfer learning kind of pipeline. You freeze the model, you train your data, then you unfreeze your model, and then you train a little bit more with a smaller learning rate for fewer epochs. And that usually works well. Many times that's like that would be like the cookbook recipe, but still, as everything, there might be exceptions. And I have seen personally data that the best thing, the best results after a lot of experimentation was, okay, we get the pre-trained model, say in that case, it was ResNet 34, I think. No, ResNet 50, I think it was. And since the beginning, unfreezing the whole network and then putting a few, okay, we remove the head, the linear layers, replace them with 3 linear layers, unfreeze everything, and now train the whole thing, including the ResNet. It was something like 50 epochs. I mean, it took like 1 hour probably, so not that long. And that led to the best results since the beginning. So that's also possible, and as usual, it depends on the application. The traditional process to do it would be freeze, train, unfreeze, fine-tune for a little bit, and that's usually the best way to do it, but not always. Okay, so that. All right. Is there any question about this? So let me see the chat. I see a few questions in the chat. in a CNN from one layer to another, we are most of the times more filters than in the previous layer. My question is why? Is there a reason advantage to do that? That's a really good question and not a very straightforward answer. And I'm gonna be honest, I am not aware of a methodical, like, real research about that. One of the things that I am aware of is that by reducing, why is it like gray instead of black? Can I do it maybe like this? Yeah, by reducing, because you're going like, you start like this, the activation volumes is reducing, right? Like then it goes like this, but the depth of the network goes like this, and then probably it goes to something even smaller and then more volume. And that's the traditional way that if you see the architecture in any network, you will see that they follow this approach. The height and width reduces and the depth increases. As I was saying, I am not aware of a legit scientific reason for this. There might be. But one of the things and advantages of doing this is that by reducing the size, because all these convolutions, like the channels, when you're doing like these convolutions that have a depth, the depth convolutions are happening in parallel because the filters have the same depth as the input volume, right? So the filters in here will have the same depth as here. So all those convolutions happen in parallel, whereas the convolutions in every step, and even so they might happen in parallel depending on your computer hardware, but not necessarily. I mean, if you're parallelizing the convolutions, the depth is going to happen at the same time. When you're doing the convolution, the steps that you're doing in the height and width might happen in parallel, but might not. And so if the resources are not enough for parallelism, this would be sacrificed, but the convolution in the depth not. So for me, that's probably one of the reasons. It's more efficient to have this kind of depth. But that's like just something that I'm thinking about right now, because I don't have like a more scientific answer about this. For me, it makes sense because of this that I'm saying. There might be some other reason, but I am not aware of that, to be honest.
Okay.
And if you see, most of the models will follow this trend of having more depth in the final layers, but the smaller volumes. Also, this allows you to, because when we were doing max pooling, for instance, this allows reducing the amount of elements that you are computing. And by the end, if you are using techniques that are like the one I just explained, that instead of doing a flattening operation, you do this kind of average per channel, that's also more efficient if the number of elements you're averaging is smaller. But these are like reasons that I can think about optimization, like to make the process more efficient. I'm not totally sure if there's a study that shows that it's better for performance in terms of accuracy. Not aware of that. There might be some reasons. Let me see the other question. How many fully connected layers are best at the end of the model? 2, 3, 50? Yeah, that's tricky as well. I have never seen 50 linear layers in the end. It's usually like 3 or 4.
Yeah,
And
just saying, because I am a little bit lost, like deciding this part of I could call the architecture of the network.
Yeah, I get it. And you're totally right. This is kind of the hyperparameters that you have to define. And if you wanted to be like really formal about it, you could do like a search. And you will do a search. Or last week we were talking about doing some optimization, like Bayesian optimization, to find the optimal number. And that would be, and there is a research on doing this. I mean, how do you define the number of layers and all this?
Yeah,
Usually sorry, say that, yeah.
Yeah, because in the first assignment, my team and I, we tried to make a kind of grid search for parameters, and we had to stop the process because it was too long.
Yeah. Yeah, probably if you're doing grid search in that case, probably you were doing probably searching a lot, or probably doing too many epochs to run your
maybe
models. Yeah, that's tricky as well. Yeah, absolutely.
we were playing
The-
with that, but we were wondering if there was a rule, but like there isn't, right?
No, not really. Not that I'm aware of. I mean, although, as I said last time, there is research on this, like optimization techniques. I remember some time ago, I saw some study that was using genetic algorithms to find out what's the best number of parameters. And last week we were talking about using Bayesian optimization. I mean, you can do, because in the end of the day, you can see the optimal number of parameters as an optimization problem. There is an area now called NAS, which is network architecture search, which is doing deep learning to find the best hyperparameters for deep learning. So that's like, okay, use deep learning. If deep learning solves this kind of problems, okay, use neural networks to find what's the optimal number for larger neural networks. I mean, there's a lot of research on this. So, but there is not a unique answer. Yeah. So in that sense, I mean, just like some hand wavy way of looking at it is that the initial layers, like the body of the pre-trained model, is going to be the part of the model that is going to be abstracting the more generic features, right? The more generic features, and every layer you will have abstraction of more particular features of the data. So as we have seen, like probably the first layers are going to identify lines, different orientations, and by the time you're arriving to the 15th, 20th layer, you will have like faces and more complex objects. The final linear layers are just going to be the ones that are going to be recognizing characteristics that are very particular to your data. And in many ways, they are going to be, well, they are linear transformations, right? They are affine transformations followed by nonlinearities. But in the end of the day, they are going to be doing transformation of the data coming from the CNN. So in that sense, given that they are just doing this kind of fine-tuning to the peculiarities of your data, for this kind, because the core abstraction, the complex abstraction has already been done by the convolutional neural network part. So the intuition is that since now you're only doing like a very, very, okay, let's get these particular characteristics of my data, you wouldn't need that many layers to abstract that, right? And the more complex the data, and the more different the data is from the data from ImageNet in this case, then probably the more layers you will need. And it is the cases when you will actually need to have probably more convolutional layers even, right? Like even including convolutional layers. But if the data is like somehow similar to that of ImageNet, I think a few layers will allow you to do just the final distinction of data. And that's the reason you will see that 3, 4 layers, maybe 5 layers sometimes, but not many more.
Okay, thank you. So you can skip question number 3, I think.
Okay, I can skip question number 3. Okay, question 4. Is there a tool to design the CNN like the draw blocks you show in the video? Yeah, absolutely. There is a website I use for that. Let me see if I can find it. To do the drawings is NNNSVG. If you Google NNN, like NNNSVG, I think you find the website. It's a very simple website. I don't remember the name of the author, but it's really good, like to do the drawings. Let me see. I'll put it I can put it in an announcement actually. Let me see if NNNSVG. Yeah, and then SVG. Alex, yeah, this website. I will paste it in the chat. Oh yeah, someone did. Okay, thank you. Thank you.
Thank you, Juan Luis. Thank you, Professor.
Yeah, no, good questions. Yeah, let me see. Are there any tools to debug neural networks we can make informed decisions in regards to other removing layers? There is a tool called Weight and Biases. Now you can actually access the weight and biases. It's a company. I mean, they do And their intention is that precisely. You can monitor many experiments with different hyperparameter configurations, leave them running, and then you will be monitoring. Like you imported the library from weight and biases. Haven't used it in a while right now, but this WBS. Okay, you import weight and biases library, and then it allows you to track all these kind of different configurations for. It's for tracking mainly, but it's really good. It's really good. I think many people for training large models would use it, like in real production settings. And you can have a license, like a student academic license that is free. So yeah, weight and biases, I would say, would be probably one of the best tools I'm aware of to track what's the best way to train the model. Yeah, which is exactly for tracking if you change hyperparameters, number of layers, learning, and it delivers like very nice plots to see the performance with different hyperparameters. I probably should do a tutorial on that. Yeah, that's the one I'm aware of. Recently, this is not to do with the. I was looking at this at the last NeurIPS, and I was talking to one of the scientists. But I had the sticker. Doesn't matter. But there is a tool called it's 51. The library is 51. That's not for tracking the performance of the neural network, but that's really cool to analyze the data, your data. Is I'm not wrong. Let me just get the exact name. 51 library. Yeah, 51 is called. Voxel 51 is the company. Yeah, I'll do that. This one I haven't used, like 51. I just saw it in last NeurIPS, and it was really cool to analyze the data. Really, really cool for that. Yeah, but yeah, definitely weight and biases is a. There will be hopefully a tutorial about that because it's really useful. And this 51 is also, as I was telling, really interesting. But this was the way I looked at it is more to do with analyzing data because it transforms images, particularly images for computer vision, into a space, and you can actually see like the distribution. It's really cool because you can see the kind of the distribution of your data, of your images, and you can actually see how one particular point, one image, is an outlier. So you have your nice distribution of data, like this 3D cloud of data, and then you see like a manifold here, and then you see that there is one point here, and you click on the point, and you see the image that point is representing. And you can actually, it helps a lot because you can see that all the images are, I don't know, black cars, but you click that point and it turns out that it's a red car. It's like an outlier, something that happened to be, I'm just saying something stupid, but you can see actually these kind of differences in your data by analyzing distributions. Is 51. I haven't used it though. I haven't tried myself, but I was like looking at the demos and projects that they had running in their stand in the conference, and it seemed quite cool actually. I was talking actually to one of the Laura Ramos is the name of the scientist I was talking to from Colombia. Yeah, but also worth trying. I haven't used that one, but looks pretty cool actually. All right, and I don't know, is there any other question?
Not here.
All right, then I think if there's no other questions, I mean, that would be all for today. As I said, we will not have a session next week so that you have a chance to catch up and review for the quiz. The quiz is going to be open from Tuesday. Once you start the quiz, you will have 2 hours to complete it, but I guarantee that you will take less than that. You can access all the materials that you want to. My advice would be try not to ask the question just to ChatGPT. I haven't tried to see if it could give good answers, but it might. I mean, like the newest reasoning versions, I think they might lead to good answers. Yeah, still, my advice would be try to solve them yourselves. If you want to work in teams, that's totally fine. I mean, I most of the things you will do in real life is going to be teamwork, so an issue. So my advice would be only that you understand the answers and you try to arrive to the answers on your own. But you can ask, like, if you have questions and check with your team, that's totally fine. All right, well, thank you very much. Then, as we said, the first NVIDIA workshop will be, I'll ask for it on the 22nd, right? 22nd of February. I'll fill in the form already, so for the 22nd. Usually 2 weeks is enough anticipation to ask for it, so yeah, should be fine. If there's need, if by any reason it cannot be on that, then I'll let you know and we'll do it the week after. But tentatively it's going to be on the 22nd. I'll confirm in Canvas. Right? The one of the diffusion models, as I said, is going to be on the 10th or on the 11th week of the class. So because last week is going to be covering some diffusion, so I think it's perfect. So that we use the workshop to cover the last part of the last week of the materials. So that I think it's going to be on the 10th, which is going to be like the second week of March. I don't remember exactly the date, but it's going to be like the second or third week of March. And that has to be on a Saturday or a Sunday, because that workshop is definitely longer. And that workshop we will do like it is intended to be done. This one of fundamentals of deep learning, since we have seen everything, like, as I said at the beginning, it covers what is, what is machine learning? I'm trying to remember the topics, but this is a very, very basic introduction to machine learning. It talks a little bit about expert systems. It talks about the difference of expert systems versus machine learning models. It talks a little bit about what is supervised learning, what is unsupervised learning, and so on and so forth. So we can go very quickly with the material because we have seen everything with a lot more detail. Right? And we will focus on the labs. The labs are really good. So I think we will spend most of the time working on the labs, which should be like a review of what we have seen so far, with some additional concepts, like there is some style of programming that is very nice. Some of that I don't like that much, but it's also using PyTorch. So it's going to be all within what we have seen so far. Okay. So, well then, thank you very much for joining today. Let me see if I can stop sharing, or I will stop recording.